All right, so there's 3 questions from chapter 16 and 1 from chapter 17. Again, feel free to send me additional ones, but just try to get them to me by middle of the day tomorrow so that I can answer them before the evening, so you can get them for studying before the test. Okay, so this question, let's kind of follow the same routine of writing down symbolically what the K is equal to. So here it's CO2 squared over CO squared times O2, and this is 140, 1.4 times 10 to the second. And they tell us this is at equilibrium, so we don't actually have to do an ICE table. This is already equilibrium values. The thing that's confusing here is that they give it in terms of moles and liters instead of giving it to you in molarity already. So the concentration of the CO2 is 0.4 moles per 5 liters. The O2 is 0.1 moles per 5 liters. So we need to just convert those to molarity, plug them into the K expression up here, and then solve for the, let's see, what is it? The CO concentration. Now, sometimes these do give you guys different numbers, like it'll have the same basic question, but it'll substitute in different values just to kind of mix it up for people. So if your numbers don't match exactly, that's why. So it's okay. All right, so the CO2 here is 0.08. The O2 is 0.02. So I'm just going to go ahead and solve that out. And I'm getting that, I'm not going to go through all the rearranging of it for you. You guys, I was going to say you guys can do that. I need to square this value first, though. Don't want to forget that. Okay. All right, I will work through it with you because I realize this value is squared as well, so I don't want you guys to get confused. So I don't have a ton of space, but I'll do it. So 0.08 squared. The CO is the value we're looking for, so that's, let's call that our x squared. And then this is 0.02 equals 140. Okay, so I'm going to rearrange that. Move this stuff down so you can see better where I'm going with this. Okay, so I'm going to rearrange that. I'm going to put the x squared on this side, isolate it from everything else. So I basically multiplied by x squared. Now I'm going to put 0.08 squared over 0.02, and then that 140 on the bottom. So to get x, there we go. I'm going to need to take the square root of all of that. So this comes out to be 0.0 478, which isn't one of the choices. Oh, it's in moles, that's why. No wonder this question is confusing. So this is molarity of CO, and they're asking for the number of moles present in the flask. I'm not going to do this to you. I'll give it to you in molarity and ask you for molarity. That's why this question, why people struggled with it. So it's giving you molarity here. So now we have to take that 5 liters and get it back to moles. So 5 liters times 0.04 0.78 moles per liter. So 5 times 0.0478, and that one comes out to 0.239 moles. So everything else is pretty straightforward except for the fact that they give it to you in moles and liters and ask for it in moles and liters. So you have to go into molarity, do the problem, and then go back out at the end. Okay? All right, next one. Let's see, that was 40. Let's do 49 next. Okay. Consider the following reaction. Equilibrium concentrations are given and the equilibrium constant, and we just have to find NO2. So this should be fairly straightforward. Let's see if there's some little thing I'm not seeing that makes this difficult, but we'll see. So K is equal to NO2 squared over N2O4. So the NO2, that's our X. So we'll say X squared over 0.037 molar. And this is all equal to 0.21. Okay, so X is going to be equal to the square root of 0.21 times 0.037. So that should be just that straightforward. It's possible that the question just came up from, I don't know, not squaring it in the expression or something like that. So this comes out to be 0.088. So in scientific notation, that's this one, 8.8 times 10 to the negative second. Okay. And 50. It's funny, we're not even hitting any like ice table stuff here. So if somebody wants to throw one of those at me just so we can do a practice problem, that's fine. But these ones are actually already giving you equilibrium values. So that's interesting. Okay, so we're looking for equilibrium concentration of CO2. Now, my guess is the reason why this question came up is because the reactant here is a solid, so that's not included in the equilibrium expression. And my guess is that threw one of you because you're like, where's the equilibrium concentration of that? How can I figure this out? And you don't need it because it's a solid. So concentration of CO2, concentration of NH3 squared, that's all going to be equal to the K. So they give you the NH3 expression, or sorry, the NH3 equilibrium concentration. We're going to call CO2 our X, and this is 2.5 times 10 to the negative third squared. So X is just going to be 1.58 times 10 to the negative eighth divided by 2.5 times 10 to the negative third, and then that whole value squared. So X comes out to be 0.00253, or 2.5 times 10 to the negative third. Okay. All right. Last one is in chapter 17. Calculate the pH of a 0.450 molar KBRO solution. Oh, I know why this is difficult. Okay, so let's pretend that instead of this value, we kind of skipped over this KB-Ka relationship. So here's how it would look for you if you were to be asked this on the test. So I would give you the KB for BrO minus, and I'm going to tell you that. Don't worry about how I'm doing this because I'm not going to make you do it. Okay, so the KB for our BRO minus is 3.57 times 10 to the negative 6th. Okay, so just pretend like that was the information that you were given for this problem. So I'll go ahead and do it just so that anybody who wants to can see another example of one of these. So the reaction is BRO minus plus water forms HBRO plus OH minus. Okay, so we set up our ice table, 0.450 minus X plus X on both of those. Thankfully, the K is small enough so we can just ignore this guy. So our whole thing is going to be equal to X squared over 0.450. Or X is equal to the square root of 3.57 times 10 to the negative 6th times 0.450. So that's going to be the concentration of OH minus, and then we're going to have to convert that to pH. Okay, so I get that X is equal to 0.00127, we'll say. And remember, this is the OH minus concentration, not the answer. So we need to go ahead and I'm just going to take the negative log of that, and then that'll give me the POH. And then I'm going to subtract that from 14. So I get the POH being 2.896. So the pH is 11.10. Okay. Notice like they put that as an option because they're trying to throw you. So you want to make sure you're walking through each of those steps. Okay. So that's the last one. Let me know if there are any additional.